Theorem 2.8 is calculating the area of a parallelogram. So it states if we locate vectors u and v such that they form adjacent sides of a parallelogram, then the area of the parallelogram is given by the magnitude of u cross v. There's a quick proof that I've supplied as well. It's over here. So we know the area of a parallelogram is base times height. So the magnitude of u times the magnitude of v times the sine of theta gives us R2. So the magnitude of u is that distance there, and then this height is based upon v and the sine of theta from the previous definition. And that gives us the magnitude of u cross v again from a previous video. All right, so we seem to have a pretty lengthy problem number 211 that I've got supplied here. So we're given 3 points. A is 3, -1, 2. B is 2, 1, 5. And C is 1, -2, -2. And we're tasked with finding the area of the parallelogram A, B, C, D with adjacent sides A, B, and AC given. So we know that it's going to look something like this. So we'll have A here, we'll say B is here, and C is here. So we're given those pieces of information. And we're looking for the parallelogram that's going to be formed, so D is going to be out here somewhere. Okay, well, we need to first find the vectors A, B, and AC, and we can do that using the points given. So this equals, let's see, A going to B, so we're going to take each point in, or each value in B and subtract it from A. So we're looking at 2 minus 3 for the first value, 1 minus a -1 for the second, and then 5 minus 2 for the third, which gives us -1, 2, and then 3. And then we also want to find AC. So now we're going to use A, but we're going to use C as our first one. So 1 minus 3, -2 minus that -1, and minus 2 minus 2. So it gives us -2, -1, and then -4 as our AC. All right, so in order to do this, we're going to need to find, we can let AB be U and AC be V, and we need to find the cross product of these two. We'll use a determinant method. I think that's a little easier to see. Certainly easier to do, I think. So our AB vector is -1, 2, and 3. Our AC vector is -2, -1, and -4. So for I, we use 2, -1, 3, -4. Oh, excuse me, we subtract the J part. So -1, -2 is the first column, 3, -4 is the second. And we add the K. These are our determinants. So here we have, what is that, -8, minus a negative 3 I. And here we have 4 minus negative 6, and that's j. And here we have 1 minus negative 4, that's k. So that's going to give us, what are we looking at, negative 5 and minus 10, j, and minus, excuse me, positive 5. Okay. All right, so now we've found what AB cross AC is, and according to this area of our parallelogram, we're going to need to find the magnitude of this. So again, our U is AC and our V is AB, or vice versa. So let's find that. All right, magnitude, AB cross AC. All right, so our first value is negative 5, so negative 5 quantity squared. Our next one is negative 10, so negative 10 squared. The last value is 5, so 5 squared. That's the square root of 25 plus 100 is 25. Square root of 150. So we take out 25, and that's going to be a 6. So it's going to be 5 root 6. This is the area of the parallelogram. And what do we need next? The next thing we need is to find the area of the triangle ABC. Okay, so that shouldn't be bad at all. So first of all, remember, that's A, that's B, that's C. We're looking for the area of this triangle. Well, the area of our parallelogram is that 5 root 6. So if I cut this, I just bisect this, we should have halves. So the triangle, or area of the triangle ABC, should equal 1/2 area of our parallelogram. And that's probably misspelled, I apologize. Anyway, that's 1/2 5 root 6. 5 root 6 over 2. So this should answer part B. And part C, the distance from point A to the line BC. So we're looking for this distance here. So I'm going to label another point E. We're looking for that distance, assuming the closest point there, essentially the height. So that length, AE, is what we're looking for. And note that area of the triangle ABC is equal to 1/2 base times height. which equals 1/2. The base is going to be the distance from BC, and that's going to be multiplied by the height, which is AE, and we're looking for AE. Now we have the area of the triangle. We just calculated that. So this is going to be equal to 5√6/2. That's what this area is. All right, and that is going to be, let's see, and then we're going to multiply through. We can multiply this through by, let's see, by 2 over BC. So I'm left with 5√6 over the length of BC is equal to AE. And AE is what we're looking for. Well, essentially, we need the magnitude of BC. And that should give us our answer. So in order to calculate that, well, we need those values. So B and C, so we're looking at 2 minus 1 and 1 plus 2. 1 minus -2 is 1 plus 2. And then 5 plus 2 again. So we're looking at 1 squared, 3 squared, and 7 squared. All right. And again, just go up and take a look at those numbers. Just look, open your book and look at it. And that's 5√6. All right, so that means AE equals 5√6 over 49, 59. So √59. And we can combine that if we want, but it looks fine right now. So let's say that that's our answer. And this is part C.